Okay, in our previous class, we have learned about the pure strategy games. So in pure strategy games, each player will adopt a single strategy as the optimal strategy. And in that case, we will have the saddle point or equilibrium point. Here, mixed strategy games. So these mixed strategy games occur when each player select an optimal strategy that does not result in an equilibrium point, means that there is no saddle point when we apply the minimax and also the maximin criteria. So in mixed strategy games, the maximin value and also the minimax value for player A and B does not have the optimal pure strategy. So in this case, each player will play their strategy for a certain percentage of time. That's why we call it as a mixed strategy. For example, if let's say player A have strategy 1 and strategy 2, so basically he will mix strategy 1 and strategy 2 throughout the time. So the goal of this approach or these mixed strategy games is that the expected value does not depend on what their opponent's strategy. And this will all occur if the expected value of each strategy is the same. Let's look at this example. So in this case, if we try to apply the maximum of minimum or maximin and the minimax criteria. So for example, for the first row, 4 and 2, minimum is 2, and 1 and 10, the minimum is 1. Then we try to select the maximum out of this value. So 2 is the maximum value. Then for every column, 4 and 1, 4 is the maximum value. And 2 and 10, 10 is the maximum value. And then we try to find the minimum between 4 and 10. So in this case, 4 is the maximum, 4 is the minimum value. So we can say that the strategy for player X and player Y is not the same. Player X will choose strategy 1 and player Y will choose strategy 1 for Y. So in this case, we can see that the value of the game is between 2 and 4. Okay, so this is based on the value that we got here. Okay, 2 and 4. So the value of this game is between 2 and 4. So what is the optimal strategy for both players, player X and player Y? So in order to solve these mixed strategy games, we have several methods. Okay, but in this example, we will try to look at the expected gain and expected loss. Now, look at the player X strategy. So now, assuming that player Y, so player X will assume that player Y will choose the first strategy, Y1. Okay, so in that case, for player X, they will play strategy 1 for P, means that probability of P, and for strategy 2, 1 minus P. So in this case, if player Y choose strategy 1, so the expected gain for player X will be 4P plus 1 minus P. Now, if player Y choose strategy 2, the expected gain for player X will be 2P plus 10 times 1 minus P. In this case, it doesn't matter what is the strategy chosen by the opponent, in this case a player Y. So the expected gain for player X will always be the same. So in this case, if player Y choose strategy 1 or player Y choose strategy 2, the expected gain for player X is always the same. So that's why we can equal these two equations. 4p plus 1 minus p equals to 2p plus 10 times. So solving for p, we have p equals to 9 over 11. And that means 1 minus p equals to 2 over 11. Now if we convert this into a percentage, so we can say that for player X, okay, so p 9 over 11 convert into percentage, this will be, the value of p will be around 81.82%, and for 1 minus p is around 18.18%. That means throughout the game, player X will adopt strategy 1 for 81.82% and strategy 2 for 18.18%. Now if we try to find the value of the game, so we just substitute the value of p into any of the equation. You can use this equation or this equation. Just substitute with p. So in this case, we have the value of the game is 3.45. So you can see that this value is actually somewhere between 2 and 4. And using this mixed strategy, actually player X and player Y have obtained better result compared to the previous value of game. So for example, previously, if you look here, player X, the outcome will be 2. Okay, but now he can increase to 3.45. Then for player Y, remember player Y tried to find the minimum and player X tried to find the maximum. So player Y, instead of 4, now he can reduce to 3.45. So both parties or both players will get better result. Now in terms of player Y, assuming that player X choose strategy 1, so in this case, there is 3 probability that player 1 will choose strategy 1, player Y will choose strategy 1, and 1 minus p probability that player Y will choose strategy 2. So the expected loss for player Y is 4 times p plus 2 times 1 minus p. And if player X choose strategy 2, the expected loss for player Y will be 1 times p, or just p, plus 10 times 1 minus p. Okay, then we can equal these two equations. So 4p plus 2 times 1 minus p equals with the second equation. So you will end up with p equals to 8 over 11 and 1 minus p equals to 3 over 11. If we convert these p values into a percentage, so for p, it will be somewhere around 72.73%, and for 1 minus p, it is around 27.27%. So this is the strategy for player Y. So they will choose strategy 1 for 72.73% of all throughout the game, and they will choose strategy 2 for 27.27% throughout the game. Example 4. If we try to solve this using the minimax and maximum criteria, so for example for team A, using maximum, so first you find the minimum 1 and this is 0, so the maximum is this one, and for each column, for the maximum value, this is 15, this is 6, so the minimum value is 6. So we can see that there is no optimal strategy. So it means that we have to adopt the mixed strategy. Okay, so we assign P for strategy 1 and 1 minus P for strategy 2. Then, if let's say team B choose strategy 1 or B1, then the expected gain for team A is 1 times P, which is 1 plus 15 times 1 minus P. And if team B choose strategy 2 or B2, then the expected gain for team A is 6 times P plus 0, because 0 times 1 minus P is 0. Then we can equal the expected gain for these two strategies. They must be the same. Try to solve for P. So in this case, P will be equals to 15 over 20. And if we convert into percentage, this is somewhere around 75%. Okay, and 1 minus P is 25%. Now for team B. So for team B, they will assume that team A choose the first strategy. So in that case, before that I just put Q and minus Q. So the expected loss, if team A choose the first strategy, will be 1 times Q plus 6 times 1 minus Q. And if team A choose strategy 2, now the expected outcome for, the expected loss for team B is 15 times Q plus 0. Why? Because 0 times 1 minus Q. So now we can equal these two equations and solve for Q. So in this case, Q will be 6 over 20 or somewhere around 30%. And in this case, 1 minus Q equals to 70%. So we can summarize this situation. For team A, they will adopt the first strategy, which is to run 75% of the time, and will adopt the second strategy 25% of the time. And for team B, they will choose the first strategy, run defense, 30% of the time, and they will choose the second strategy 70% of the time. So if you want to find the value of the game or the expected gain or expected loss, we just simply substitute the value of P or Q into the equation. So in this case, if let's say I choose 15Q, it will be 15 times 6 over 20, which is 4.5. Or let's say if you want to use another equation, okay, 6P, so it's the same. 6 times P, P is 15 over 20, you will still get 4.5. And you can see that this 4.5 is somewhere between 1 and 6.